So if you were graphing that line, y equals 3x plus 2, you would say, well, I know that my y-intercept is 2. I know that my slope is 3, so I could go up another 3 and over 1. And I could get my graph. Now, what we're going to be doing in section 3.2 is looking at what happens when there's a negative, a reflection in the graph. So first of all, I'm going to look at, well, what would happen, and I'm going to look in particular, here we've got the point, and I'm going to label 1, 5. What would happen if you replace the x, I'm going to do this a little bit lower, I'm going to change colors. What would happen if you replaced the x with a negative x? Now, if you had this when you were graphing lines back in grade 10, what would you do? You would just simplify your equation, right? 3 times a negative x, you would rewrite this as y equals negative 3x plus 2. And so if we would go to graph this one in green, we still have a y-intercept at 2, but now our slope is negative 3. So we go down 3 over 1. Like this. How do those two graphs compare? Can you see that one is a reflection of the other one? That all you would have to do would be, if you reflected this first blue graph over the y-axis, you would get the green graph. And just as a check, if I take this point 1, 5, and I flip it straight over with the green graph, what point would I end up at? Negative 1, 5. So I want to just do a quick check. Is negative 1, 5 the correct point on this equation? If I plug in negative 1, do I get 5 for y? And the answer is yes. So when we replace the x with a negative, that flips the graph over the y-axis. I had one already, thank you. If we replace the y with a negative, and again, if you had this back in grade 10, you would do some rearranging. A couple of ways you could rearrange. You could move the y over to the right side, all the numbers over to the other side. Or you could multiply both sides by a negative 1. Now, when you multiply both sides by a negative 1, you're multiplying the entire equation on the right-hand side by a negative. And so you would get negative 3x minus 2. What does that look like? Well, here we would have a y-intercept of negative 2, and the slope would still be negative 3, so we go down 3 over 1. And the question is, how does this relate to our original graph? So our original graph is the blue one on the top. What kind of reflection happened here? Can you see that it has been flipped down and over the x-axis? Now, if we think about the point 1, 5, if it got flipped down, we should have the point 1, negative 5. Is that the case? If you plug in 1, sure enough, you get negative 5. So a couple of other things I want you to notice in this. Does it make sense that when I reflected over the y-axis, which we're going to call a horizontal reflection, that was our green graph. On our green graph, that point didn't change. Why doesn't that point change? Because our x-coordinate was 0. In fact, everything that happened with the x being changed to a negative x, what it did was change our x-coordinates. For example, another point on our blue graph is -1, -1. And on our green graph, the x-coordinate gets multiplied by a negative. From our black graph, which point doesn't change? That's our x-intercept, because when you flip something down, that's not going to change. And if we look at what happened to our points, it's our y value that changes. So I'm going to get you to, we're going to skip the getting started, skip the construct the understanding, go directly to this page here. And you have some space to the left of that reflecting. I would like you to add the following notes to the left of this. I'll write them at the bottom, but on your page you have a column to the left-hand side where you can write some notes, correct? So just to the left of this yellow box, we're going to write the following notes. So we're going to start with y equals f of negative x. And we're going to say if the negative is with the x value, and just to use some language that we've talked about before, that's inside the function. If that negative is with the x value inside the function, I want you to think of the x values. So then the x values get multiplied by a -1. In other words, you will change the sign of the x values. And as far as what does that do to the entire graph, it flips the graph over the y-axis. So if that negative is inside the function, it's with the x values, that means your x values are going to get multiplied by a -1. Secondly, if you have negative y equals f of x, or more commonly, because we like to get the y by itself, there is a negative outside of the function, y equals negative f of x. So can you see how I'm talking about the negative being inside the function when it's with the x, and outside of the function when it's outside of that function notation? So if the negative is outside the function, then we multiply the y values by -1. If you do that, if you think about a y value going from positive to negative, it flips over the x-axis.